Okay, Math 30-2, so I'm going to do the polynomial assignment answer solutions here. This question said, which of the following is not a polynomial, and explain why. It used to say explain why, but not anymore. We can explain why it is as we go through this as well. So I'm looking through this, I'm looking at certain pieces. So we're looking at just the x's here. So we're looking at the x's, and we're looking to see where they are and what kind of exponent they have, all right? If you don't see an exponent, you assume it to be a 1, so that's okay. So you can see that 1, 3, and 4 all have exponents of 1, 2, and 3 respectively here, and they're in the numerator, so that's the key. All right, so they're in the numerator, they all have positive exponents, so they look very promising. So I'm going to say, oops, sorry, I'm going to say that 1, 3, and 4 are polynomials. The reason I'm not saying question 2 here is because where it is, like it's x is in the denominator. This is in a bad spot, right? It's not really a bad spot. It's just this makes it a rational expression. It would have a negative exponent if it's in the denominator like that. So which of the following is not a polynomial? Is not a poly, right? Just because of where that x is. All the numbers, like all the other numbers, it doesn't really matter what those kind of numbers are. They can, as long as they're real numbers, you're fine. So 6 over 5 is a great number. 2 over 3 is a fine number. Even like square root of 2, like something that said like this, as long as the x is not inside, as long as these two things are separated, then that's fine. But as soon as you start putting that underneath the radical sign, that's not good, right? So just be very careful about those things. We're going to complete this chart here. Now to complete this chart, I have Desmos ready to go here, or just the graphing technology, anything. But some of this we can do before we start. Like just by looking at this, I can say that the degree of this one, the highest exponent that this has, is 1. The highest exponent here is 2. The highest exponent on this one, I believe, if my head isn't in the way, yep, is 3. So those are just looking at the exponents here. The domain for all of these, because these are pretty abstract, they're not dealing with anything real world, they're just going to be XER. Because of the degree of this one, because it's an odd degree, 1, 3, 5, etc., I could say my range is XER. And you can see that from the graph later on. I could say this one's XER as well because it's also an odd one. Right? Evens are going to have a top or a bottom, and they're going to stop somewhere. The number of x-intercepts. Well, I know that the maximum of this one has to be a 1 because of the degree. This tells me the max x-intercepts. If I needed to figure that out, what is the maximum number could be? It doesn't necessarily mean it has that many. It just means that is the maximum. If you remember, I can't remember if this lesson or not, but the constant value, the value that's at the end here, tells us what the y-intercept is. Remember, to find the y-intercept, you can make x equal to 0. That's what you could do. So x is equal to 0 for that. And you mathematically could do that. You could just plug in 0 into the equation up there, and you'll notice that you'll get whatever that constant value is. I think this is plus 3, right? Yeah, plus 3. So those are your y-intercepts. They're just whatever these constant values are at the back here, including the sign too, so that's important. This one here, you can't see it, but it's a plus 3 there. Okay? End behaviors, I probably could try to figure it out based on the leading coefficient. Remember, that's going to help us out. The leading coefficient is going to help us figure that one out. All right, number of turns, I probably want to just look at the graph to figure that out. It just always happens to be, could be 1 less than the degree, which just happens to be, I'll just write that down here. 1 less than the degree. Okay, but it's just probably best to just look at it. I know this one's going to be 0 because 1 less than the degree is 0, and you can't go less than 0. A quadratic. This one here is the quadratic because it has a square in it. Yep, because there's a degree of 2. It's 1 less than that is 1. Quadratics always had to have 1. Just if it didn't have 1, then it would be going up and down. It wouldn't change direction. And this one here could be 2. It could be 1. It could be 3. Or it could be not 3. It could be 0 as well. We haven't got to look at the graph for that one. Because this one has a negative leading coefficient, you can look at this, the first one, because it has a negative sign here. I know that's going to be going downwards. The slope is negative for that, so it's going to have this kind of direction to it. Because the leading coefficient of this one is positive, I know that this one's going to be opening upwards. And because the leading coefficient of this one's negative, it's also, because it's odd, it's also going to be going downwards like a kind of like a linear graph. And so we might have a little bump in it though. So that will help me figure out the end behaviors here. So since I know that this is going downwards, it's got to start off in quadrant 2, and it's going to end up in quadrant 4. Okay? Because this one's opening upwards because of that positive leading coefficient, I know that this is going to end off in, if I were to draw that out slightly there, it's going to start off reading from left to right. Quadrant 2, that's a 2, you can see that, to quadrant 1. Okay, I'm just going to put down numbers on the bottom here. Same thing, the same logic for this one is the first one here. So because it is going downwards, it's going to start off in quadrants 2 and end off in quadrant 4. Now for the rest of them, I'm just going to look at the graph to figure that out. So I'm going to pull out my Desmos here. Here's my Desmos. What I'm going to do first of all is I'm going to type them into my calculator. I'll be right back. Okay, so I've typed them into my calculator here. I got 1 here. So this is the negative 5x plus 1 graph. I have them all unselected here. Yeah, so it's going downwards. You can see here that my x-intercept, I have one of them, crosses at 0.2 if I had to find that. So the number, all I care about is the number of x-intercepts. It's going to be 1. Now that one I could just set is always going to be 1 because it is a linear line. It has to go across the x-axis. It's just good to verify that. Let's look at the next graph here. Let's turn that one off. Okay, so this is a nice little quadratic shape. You can see that it has 2. Like this graph could have been up a little bit higher and you only had 1, but this one technically has 2, so that's good. So let's put a 2 here. I don't know why I had to put a positive on that one there. Okay. We want the range of this graph as well. So let's check out what the range of this graph could be. Oops, sorry. So to find the ranges, I'm going to have to find out what the min point is. So in Desmos, you just go and click on the graph and you just pick the point. And you can see the y value is -3. So that's the lowest this graph will go. So my range, because that's the lowest point, my range has to be greater than this -3. But because that point is on the graph, you could say that as well. I'm just going to throw the YER part in there. Okay. Then we're going to look at the last graph here. Graph looks like this. You just kind of zoom. Remember, you can hold down the shift button here to kind of make it look a little bit nicer. So there's that graph. It's going up and down, up. So that's a nice cubic graph. And notice it crosses 3 times. If you want to, you can just click on them. There's the 3 of them. I'm not too concerned what they are. I just want to know how many there are. So there are 3 here. Now, turning points. Just to verify, the quadratic has 1 turning. It's going down, then up, so it has 1 turning point. This is just continually down, so that's 0 turning points. This one's going up, then down, so that's 1. Then down, then up, that's 2. So it has 2 turning points. There we go. Cool. Let's check out the next one here. This one's just a matching one. You could just match these up by graphing them, but I'm going to try my best not to graph them. So these first 3 graphs, 1, 2, and 3, they are linear graphs. So I'm going to look for just the ones that have degree of 1. So like this one here, that's linear. This one here is also linear. So these ones are going to match graphs 1, 2, or 3. You'll then look at where do they cross the x-axis. You can see that they both cross the y-axis. My bad, the constant is the y-axis. They both cross the 3. So I'm going to cross off graph 3 because that's in the wrong y-axis. Or y-intercept there, sorry. So these ones cross the 3. Both are 3, so that's good. But they both have different directions. One going down, one going up. So we have one that is a negative leading coefficient. Remember, that's the downward slope. That's a negative leading coefficient. So that's B. Notice that the leading coefficient is negative here. So this one's B. This one has a positive leading coefficient because it's going upwards from left to right. It's positive. See, that's positive. So this is D. Okay, so we got those ones without doing anything with the graphing calculator. Now the next 3 graphs are quadratic. So I'm just going to look at the quadratics. So this one's quadratic. This one's quadratic. So we're looking for the degrees of 2. It's quadratic, quadratic, quadratic. And the other 2 are cubic. So I'm just looking at these first 2. You notice that there's one with a negative coefficient and a positive coefficient. So negative means opening down. Positive means opening up. And then we got some constants here of 4 and negative 7. So let's look at this. Okay, so this one here is a negative 7. The other one has a 4 and a 4. Okay. So that's, yep. So the one with the negative 7, so that's C. 5 and 6, it's kind of hard to see from this equation which is which. So what I could do with that now, just the last little bit here, I'm just going to plug that correct into this, into Desmos here. So I'm going to go negative x squared plus 2x plus 4. Kind of see that it's slightly off to the side here. So the vertex, the top of this graph is at 1, 5. So let's see what graph that is. Yeah, so it looks like it's going to be this one here. Okay, so which one am I? That's A. So it's A, so I can cross this one off. So you have B, D, C. Okay, now the last one here, we got E and F. These are both cubic. So they're going to be the last graphs, I believe, because those are all cubic graphs. Again, we got a negative coefficient, a positive coefficient, a 1, and a negative 2. So it's going to help us out here. This is a negative 1. I'm going to cross that off because that wasn't one of our choices. This is a positive 1, and this is a negative 2. So based on just that, I can figure that out. The positive 1 with a positive leading coefficient, positive leading coefficient, and a positive 1. So that is graph F. Okay, this is a negative leading coefficient, so that means it's going downwards like that. It has a negative 2, is that right? Yep, so that's E. There you go. Pretty cool. Question 4 here. Yeah, it seems like a long assignment, but it's just more matching than anything else. Use the graph to answer the question. So this has a negative leading coefficient. You can see it starts up here, it ends down here. It's going in this direction, going downwards. If I were to draw, like connect the dot between one end to another, it's going to be going this direction. So that there is a negative leading coefficient. So I'm going to circle negative. The graph has 1, 2. So this here is just kind of touching it. Remember what I said about x-intercepts? It's where it touches the x-axis. It doesn't necessarily have to cross it. So it has 2 of them. The graph has a constant term. Remember, constant terms is the y-intercept. So that's a 4 there. Okay. And it is a cubic graph because it has those 2 turning points. Definitely not a straight line. Definitely not a quadratic. So it's a cubic graph. Hopefully you got those right. And try out the quiz if you already haven't done that already. And I'll see you in the next video. Bye.